to wiring diagrams and pinouts used in vehicle diagnostics. Now this is a very interesting chapter. I request all of you to pay a lot of attention to in this particular lesson. Now here's a detailed introduction to wiring diagrams and pinouts as used in vehicle diagnostics. Now crucial tools for understanding how electronic systems are interconnected, powered and diagnosed in modern automobiles. Okay, understand this very carefully. Why wiring diagrams and pinouts matter in diagnostics? In automotive diagnostics, wiring diagrams and pinouts are essential references that help the technicians, and they help technicians to understand how ECU, sensors and actuators are connected. Okay, so this is actual roadmap to make the technician understand how the various kinds of ECUs and sensors are actually connected. Now trace faults like short circuits, open circuits, or incorrect voltage, all these things, whenever they happen, the first and foremost reference material is understanding this wiring diagram. Test individual pins on connectors using multimeter or oscilloscope. Now when it comes to validate that signals are reaching or being sent from an ECU properly. Now without these, diagnosing electrical or communication issues in modern cars is guesswork. Now what is wiring diagram? Wiring diagram is a schematic representation of the electrical circuits in the vehicle. It uses standardized symbols to show power sources, ground connections, ECUs, electronic control units, sensors and actuators, relays and fuses, communication networks, etc. etc. And again, within communication network, where is CAN used, where is LIN used, where is FlexRay used. This schematic diagram clearly represents and elucidates to the user or the technician. Okay, now we'll see the various types of the wiring diagrams used in automotive diagnostics. First is power distribution diagram. This power distribution diagram, it shows the power and ground supply to ECUs, relays and fuses. Now when it comes to system circuit diagram, it shows the detailed wiring of one subsystem, for example, ABS, engine and lighting. So this is more like a subset of power distribution diagram. Now coming to the communication network diagram, it maps CAN, LIN, FlexRay network layout between the ECUs. Now talking about the ground distribution diagram, shows where different ECUs and components connect to the chassis ground. So last but not the least, the connector view. The connector view, the physical pin layout and numbering of the connectors. Okay, so hope all of you are getting a clear-cut idea the various types of diagrams and what exactly they encompass. Now coming to the key elements in the wiring diagram, symbols, they represent components like resistors, sensors and motors, and lines, they represent the wires, and again within the wires, solid represents power, dash represents signal, dotted represents operational or shared connection. Now I'm sure anybody with basic electrical engineering knows all these things, but for somebody who's learning this course for the first time, all this information is extremely important. Now even within the wiring diagram, wire colors offer coded like red, black, yellow. They have their own separate meanings. Splices and junctions where multiple wires join. Connectors and pins shows connector name and pin numbers. Labels, component IDs. Example ECM G104 for ground. Okay. Now talking about what is a pinout. What exactly is a pinout? A pinout is a detailed map of electrical pins on connector, usually associated with ECUs, sensors, Q2, TPS, tire pressure system, OBD-II, relays, switches, and it shows the pin number, signal name function, wire color, and sometimes expected voltage resistance values. Pinout. Now talking about the use cases, what are various uses in diagnostics? How are these pinouts and wiring diagrams used or why are they so important in the OBD perspective? First example is ECU not communicating. If the ECU is not communicating, immediately use the wiring diagram to trace the CAN lines from OBD-II port to ECU. Now talking about the use pinout of the ECU to test CAN high and CAN low for proper resistance voltage levels. Okay, now second example is sensor voltage out of range. Now check wiring diagram to find which pin on ECM receives sensor signal and which uses the sensor connector pinout to verify. Now talking about the signal voltage, 0.1 to 0.9 voltage for oxygen sensor, ground continuity and 5 volt reference is applicable. This is the second scenario. Okay, now in the third scenario, intermittent fault for DTC. So if at all there is an intermittent fault for DTC, you use the wiring diagrams to locate splices or connectors between faulty components, and you also wiggle test at those points while monitoring live data or signal continuity. All right. So intermittent fault or DTC, whenever there is an intermittent fault, immediately you wiggle test at those points where monitoring live data or signal monitoring live data or signal continuity. Okay. Now, what are the various digital tools used for wiring diagrams? The most OEMs and tool manufacturers provide interactive wiring diagrams in their diagnostic software. So these tools let you click on wires to see path and connected components. Okay. First thing is these tools let you click on the wires to see path and connected components, and they also highlight the circuits based on the system. For example, whether it's a fuel system or ABS system. Also print or export wiring or pinout sheets. All right, now let's see the various tools used by various brands. For example, Volkswagen is used ETCA or ELSA, and the main feature is wiring and service manuals. Next is All Data Mitchell, where it's a multi-brand service procedures plus wiring. Auto Data, multi-brand live wiring diagrams, and OBD Fusion Torque Pro mobile apps read sensor data using OBD-II. Now talking about the best practices for using wiring diagrams in diagnostics. The first is the practice and the benefit. Now always cross-check wire color and pin number. This is the very important practice. All right. Now this is a very important practice while using the wiring systems. So the benefit of this particular practice is to avoid the probing the wrong wire. So you have to ensure that you are not checking the wrong wire. Next important practice is use back probing pins or breakout boxes. So avoid connector damage. Next is understand circuit logic before testing. Now understanding the circuit logic before testing, prevent incorrect assumptions. Next is start from known reference points. This is an extremely common practice used by technicians. You always start from known reference point, whether, for example, either power or ground. So that way you can narrow the zero in on the fault very easily. Now talking of next important practice is use scope or multimeter with known good values. And this is how the important benefit is quantitative diagnostics. This is how you diagnose in a quantitative manner. So to summarize, when it comes to diagrams and pinouts, in this table, I'm going to talk about the feature, the wiring diagram and the pinout. The purpose is to show circuit logic and connectivity, show physical pin assignments, format, and when it comes to format, wiring diagram is schematic and pinout tabular or visual connector view. And wiring diagram is used for tracing circuits and diagnostic shots, and pinout is used for pin testing and signal analysis.